Number 10. I need to know which of the statements are true. So let's figure out if the slope of this graph is actually what Roman numeral 1 speaks of. It says the plane is landing at about 8.3 feet per second. That means m should be negative 8.3. Okay, well, this is 1500. Right here I'm at 1000, so midway would be 1250. That means I'm going down 250 and over 30. Down 250 and over 30. That would be negative 250 over 30. Reduces, and what I have here reduces to negative 25 over 3. And that becomes negative 8.3. All right, now let's do something different. Let's look at the y-intercept. The y-intercept is 1500, so this is where the plane would begin to descend. And so I see that is what Roman numeral 2 says, so this is true. Now, if the rate is actually negative 8.3, then 3 is incorrect. The rate, the slope, would not be 1/2, 0.5. The plane would not be landing at a rate of 0.5 per second. However, the plane will land in 180 seconds because the plane is descending, and look, I am now at 180 seconds. So we found the 3 that are true. Number 11. I see that 180 represents the y-intercept for this problem. This would be the number of cookies you start with before any presentations have been made. If this says 160 and then I notice that it drops to 140, but there's a point right here in the middle, that means I'm at 150 for this point. So I am falling 30, 180 to 150. Fall 30 and then move 1. Fall 30. Now, as you can see, I have done that each time, gone down 30, over 1, down 30. Look at that, over 1. I know that because I'm moving from 2 to 3. Down 30, over 1. I know that m is negative 30. So the number of cookies will decrease 30 by 30 every presentation. 6 is the x-intercept, and that represents the number of presentations I made right when there were no more cookies left. Now be careful. The STAR test words it before running out of cookies. And a lot of us, we don't agree. However, this is the statement they're using to represent the x-intercept. Number 12. We need to create a table. So all of the x values are 4, negative 1, then 0, 1, 2. There's my table. And what is the equation of this line? X equals negative 4. No, positive 4. Because we are on the right side of the coordinate plane. Write an equation of a line that has a slope of negative 5 and then a slope of y-intercept of negative 3. Just plug that into the slope-intercept form. So y equals mx plus b, and that's negative 5x minus 3. So this is the slope-intercept form of linear equations. Plug in your m, plug in your b. Garrett has 10 bracelets made to sell. That means I start with 10. That's my y-intercept. And I know that after working 4 hours, I have a total of 50 bracelets. After 4 hours, I have 50 bracelets. So 10 bracelets made, that's the y-intercept. That's where the 10 is. 50 bracelets. Now, I see that I'm given a point, and I see that I have 0, 10 is the y-intercept. So what do I do in order to write an equation? Well, I'm given 2 points. Make a table. Hold on. Make a table, x values, y values. And then make a table. Menu 613 is what we're going to type into the calculator so that we can write the equation of the line. So perform a linear regression given those 2 points. Now, if you do it by hand, all you have to do is find the slope. So that would be 50 minus 10 is 40. 4 minus 0 is 4. So 40 over 4 is 10. So the slope would be 10. The calculator will tell you that as well. Now I'm going to stop and put this example on the next video because the bell's about to ring in about 2 minutes and need to let the class in. But we'll do the linear regression on the calculator and show you exactly how to finish this problem.